Welcome to You Got Hope Chemistry. I'm Hope, and you're about to learn some chemistry. Today's lesson is going to be the first of two lessons on calculating concentrations. So there's three that we're going to do today. We're going to calculate mass percent, mass volume, or weight volume percent, either or fine, or volume percent concentration. In our next lesson, we are going to calculate parts per million and moles per liter, with moles per liter or molar concentration probably being the most used type of concentration in chemistry. So what is concentration? Concentration simply is how much solute is in a solution or a solvent. Now you can do this in lots of different ways. You could say grams per liter, you could say moles per liter, moles per milliliter. There's lots of different combinations, and so we're going to look at a lot of these different types of combinations. Of course, we are going to start with a mass percentage. Now, something that I think you should do at this time is get a piece of paper out, a nice fresh piece of paper, to make a formula sheet, because all of these formulas need to be memorized, and it's nice having everything in one spot when you're working on problems. So please get out a piece of paper, title it Chemistry Concentration Calculation Sheet, and off we go. So the first type of concentration we're going to do is the ratio of the mass of the solute to the mass of the solution, multiplied by 100%. So this is often called mass percent or weight percent, and the abbreviation is MM% or WW percent. Now the full equation written out is down here, but I wouldn't actually record this on my sheet. I like it to be a little bit more simple than this. The reason I have this written out, though, is to make sure we understand that when we're talking about a mass of a solution, it is the mass of the solute plus the mass of the solvent. Now the shorter version of this equation would be mass percent is equal to the mass of the solute all over mass of the solution times 100%. Now the key here is the masses on top and bottom have to be the same unit. So for instance, if your grams on top, then you should be grams on the bottom. Or if you have kilograms on top, you better have kilograms on the bottom. It's important to just make sure that you have the same unit, top and bottom, whichever mass unit that is. Let's start off with an easy question. It says a sample of 0.892 grams of potassium chloride is dissolved in 54.6 grams of water. Now I'm going to add a little something here. We assume that 1 milliliter of water is equal to 1 gram of water. So this is likely not only to be 54.6 grams of water, but actually 54.6 milliliters of water. This is temperature dependent. This would be at standard conditions, but we just basically assume this almost all the time. So then the question finishes off with, what is the percent by mass of KCl aqueous in this solution? All right, so starting with our equation, it's mass percent is equal to the mass of the solute all over the mass of the solution times 100%. So subbing that in, our solute is the potassium chloride, so we're 0.892 grams. This is then divided by the mass of the solute plus the solvent. So I still need that 0.892 grams. I'm going to add that to the solvent, which was water, which is 54.6 grams. Put those together and multiply by 100%. So 0.892 divided by 0.892 plus 54.6 multiplied by 100%, would be 1.61% with rounding. All right. The next question we're going to try is going to require us to manipulate this equation or rearrange it to solve for the mass of the solute. So if you feel confident, you could give this a try and pause the video now. If not, just let the video run. So let's read the question. Steel contains about 98.3% iron and about 1.7% carbon. It also contains very small amounts of other materials such as manganese and phosphorus. What mass of carbon in grams is needed to make a 5 kilogram sample of steel? So, steel is a solution. It's a solution of iron and carbon mixed together. Now this question wants to know the mass of carbon, not the mass of iron in the sample of steel. So we're going to start with the percentage of carbon because the question is asking for the mass of carbon. So I know 1.7% of this solution is going to be carbon. The solution itself is 5 kilograms of steel. So my mass of solute on top here is going to be carbon. Now I could do it for iron if they wanted to know the mass of iron in a 5 kilogram sample of steel. It would be pretty close to 5 kilograms, but they don't. They want to know about carbon, and I got to make sure I multiply this by 100%. Now, I normally wouldn't show my work for rearranging this equation, but since this is the first time we're rearranging an equation like this, I'm going to. So what you would have to do is you would have to isolate this x value. So we're going to move everything across to the other side one step at a time. So when we manipulate an equation, we're always doing an opposite operation. So for instance, because the unknown value is multiplied by 100%, to move this to the other side, I have to do the opposite of multiplying, which is dividing. So I would divide this by 100%, and I would divide this by 100%. That would cancel out the 100%. I then need to move the 5 kilograms to the other side. It's being divided by my unknown value, so the opposite operation of division is multiplication. So I'm going to have to multiply both sides by 5 kilograms in order to move that to the other side. So the 5 kilograms cancels with the 5 kilograms. So now what I have is the mass of the solution times the percentage of carbon, all divided by 100%. Now what happens to the units is the percentages cancel out, so I know my final answer is actually going to be in kilograms. So the mass of carbon in kilograms would be 0.085 kilograms of carbon. If I want to turn that into grams, I'd multiply by 1,000 because there is 1,000 grams for every 1 kilogram. The kilograms would cancel out, and I would be left with 85 grams of carbon. So these are the two general ways of asking a question, which is calculating an actual mass percent, or being given the mass percent and being asked how much solute is in this solution. The next type of concentration we're going to look at is weight volume percentage or mass volume percentage. They mean the exact same thing, it's just written in a different way. So weight volume is the same as mass volume percent. This is very common concentration used in biology. Now, this is a little bit different than our mass. Obviously, we have a volume here, but you have to be very careful with the units you use. These are always going to be done in grams of solute and milliliters of solvent. Notice how this is not solution. This is the volume of the solvent, not the volume of the solution. This is the only equation we will be looking at where we would divide by the something of solvent, volume of solvent, mass of solvent. It's always going to be solution other than this singular one. Okay, so I wouldn't normally write out the equation like this. I'd write it out as following. I'm going to make it mass volume percent just because the other one is weight volume. So I would have the mass of the solute on top, and this is all over the volume of the solvent, and this is times 100%. I'm going to write in a side note here of the units though. Make sure that this mass has to be in grams and this volume has to be in milliliters. Or you can increase those both by a factor of 1,000 and you can make it kilograms over liters. That would give you the same ratio in terms of that unit. So let's start with the first one. We're not going to be rearranging the equation. We're just simply going to be putting numbers in. So it says, what is the concentration in percent mass volume? 15 grams of salt in 400 milliliters of water. So mass volume percent is equal to 15 grams of solute over 400 milliliters of solvent times 100%. And then I just double check. Good, I've got grams and milliliters. That matches up nicely. So we got 15 divided by 400 times 100. And this would be 3.75% mass volume. Our next question is going to require us to rearrange the equation. So if you want to give this one a try on your own, please pause it now. And if not, just let the video keep running. So the question asks us to calculate the number of grams of solute required to make 50 milliliters of 0.4% magnesium chloride solution. So this is going to be our solute. Now, it's very difficult to say this is only the volume of the solvent when we're rearranging these types of questions. So the volume that you're given, you essentially assume this is the solvent only, even though it really is the solution. We have to make that assumption. So using our equation of mass volume percent is equal to the mass of the solute all over the volume of the solvent times 100%. Okay, the mass of the solvent is in milliliters, which is perfect. So I'm going to be 4.0% is equal to the mass of the solute, which I don't know, all over 50 milliliters times this by 100%. Now again, I normally do not rearrange this equation, but just because we're starting out, I'll show you how to do it again. What I would do is divide 100% across to the other side because it's being multiplied by 100%. That gets rid of the 100% on that side. I then have to get the 50 milliliters up to the other side. In order to do that, I'd have to multiply both sides by 50 milliliters because that's the opposite operation of division. I have to make sure that I double or bracket my numerator, and so it calculates that first. So 50 times 4, and then we're dividing that by 100. And so the mass of the solute is going to equal 2.0 grams. So this is mass volume or weight volume percentage, and we've done one of each style of question. So we're simply given the mass of the solute and the volume of the solvent, plug the numbers in, and we get our mass volume or weight volume percent. The second style is we're asked for the mass of the solute, but we're given the percentage. So we simply just move the 100% over by division. We move the solvent volume up by multiplication, plug it in, and out comes our answer. The last type of concentration calculation we are going to do today is called volume percent. Quite often it's really used for a liquid solution which is being made. Quite often alcohol would be a good example of it, because ethanol, which is the alcohol that we have in what we drink, is a liquid, and water is a liquid, so it's a liquid mixture, and therefore we would do percentage as a volume. Now, something that's actually pretty cool, these calculations give us a close volume, but when you put ethanol in water, so if I put, say, 50 milliliters of ethanol with 50 milliliters of water, its total volume is actually less than 100, because the hydrogen bonding between the molecules draw each other together in such a way that they actually occupy less volume. We don't accommodate for that in these calculations, but it is quite cool to see two volumes not adding up to what you would predict. Okay, so an example using alcohol would be a 40% volume ethanol solution, which is what you would find in, say, vodka or rum usually, would essentially contain 40 milliliters of ethanol per 100 milliliters of total volume. Now again, here's our equation. I wouldn't quite write it out this large. So the abbreviated version would look something like this. Volume percent is equal to the volume of the solute all over the volume of the solution times 100%. Now again, you just have to keep the units the same. So if you have milliliters of solution, then you would have milliliters of solute. Or if I had liters of solute and I have liters of solution, that is fine, as long as those units are held the same, because they have to cancel. So one of my favorite movies is James Bond movies. And of course he has vodka martinis, shaken, not stirred. And so I'm going to use that as my example here. Okay, so it says James Bond has a dry vodka martini, shaken on ice. The total volume of the martini is 65 milliliters. Okay. Calculate the volume percent of vodka in the martini if 50 milliliters of vodka is used. So the other 15 milliliters must be coming from melted ice to make up the rest of that martini. So volume percent is equal to the volume of the solute all over the volume of the solution times 100%. Now, based on the way I'm reading this, vodka is the part of the solution we're looking at. We're going to call it the solute. So 50 milliliters of vodka is being used. The total volume of the martini is 65 milliliters. And we're going to multiply that by 100%. So 50 divided by 65, then multiplied by 100%. 77% with rounding is the amount of vodka in a martini. In our next question, we are going to focus in on actually the ethanol part of vodka in the martini and in the vodka itself. So our next question is saying calculate the total volume of ethanol in vodka if 40% of the 50 milliliters of vodka is ethanol. So vodka is going to be our solution. And we have 50 milliliters of vodka. What we're going to do is we're going to figure out the volume of the solute, which is going to be ethanol. So our total is 40%. What we're trying to figure out is the volume of ethanol in the volume of vodka, times that by 100%. So what I need to do is I need to put in this volume of vodka on the bottom. This happens to be 50 milliliters. And then I have to rearrange the equation. I'll bring the 100% across by division. And then I have to bring the 50 milliliters over by multiplication. And that'll cancel out the 50. Make sure I put my numerator in one set of brackets. So we have 50 times 40. Then we're dividing that by 100. This would come out to 20 milliliters. Now this makes sense to me. I understand that 20 is 40% of 50, because if I doubled 50 to 100, then I would double 20 to 40, which is 40% of 100. So 20 milliliters of the 50 milliliters of vodka is ethanol, which is the alcohol we drink. Calculate the volume percent of ethanol in the martini if 40% of the vodka is ethanol. So let's have a go at this one. Volume percent is equal to the volume of ethanol, because it's asking about ethanol in the martini this time, over, it says in the martini, this is going to be my solution, so my volume of martini, times 100%. So in the previous question, we calculated the volume of ethanol. It was 20 milliliters. This is over the volume of the martini, which was given at the beginning of the question as 65 milliliters, and we're multiplying that by 100%. So the percent of ethanol in the martini would be roughly 31% with rounding. So this was an interesting question. We did multiple things. We first figured out the volume of ethanol in the vodka. Then we figured out the volume percent of ethanol in the martini, because the ethanol is diluted by that extra little bit of water when the martini is shaken on ice. I hope you have enjoyed this lesson of You Got Hope Chemistry. See you next time.